right, this is our first video in Unit 5. So Unit 5 is on comparing and contrasting functions. So this is my title page. So in this video, you might end up doing a lot of pausing so that you can catch up to what I have. So just to keep the video as short as possible, I'm not going to do a lot of pause time. So pause the video if you need to get your paper set up. All right, the first thing that we are going to be doing is making a huge chart. So I'm going to pull this out so you can see. So this is what the chart looks like, and you can see I'm using the whole sheet of paper on the side. So again, if you need to pause the video so you can get your paper set up, we are going to be looking at the three types of functions. So you have done linear, which you did in Math 8, and we reviewed at the beginning of this year. And then we have studied quadratic functions and exponential functions. So that's what our three rows are for. All right, first up, let's go over linear functions. So linear. So most of this is what you did in Math 8. We did add to it this year a little bit in Unit 2. So in this box, we're just going to sketch the graph. So a linear function is a function that makes a line on the graph. So a linear function makes a line. All right, in this box right here, we're going to list what we know about a linear function. So the most common formula is y equals mx plus b. The m represents the slope. The b represents the y-intercept. And we've been talking a lot about slope lately because we've been using it even though we haven't doing linear. You probably remember it as rise over run, or maybe delta y over delta x, or even y2 minus y1 over x2 minus x1. So that's really the equation that we use when we talk about linear functions. That's what you guys learned last year. Now, what's unique about linear functions? It's the only function that we've studied that has a constant rate of change, and that's what your slope is. This year, we added on that an arithmetic sequence is a linear function. And if you need to jot this down, the formula that we used for the arithmetic sequences is similar to the y equals mx plus b, but we used an equals dn plus a0. So even though last year we used y equals mx plus b, this year we use this one, the setup is exactly the same. And the other thing with linear functions, they are either increasing or decreasing, but not both. So your line is either increasing because there's a positive slope, or it's decreasing because there's a negative slope, but it won't do both. So it's just one or the other. All right, again, if you need to pause the video to catch up, please do. I'm going to go ahead and move on to quadratic. So quadratic functions, I'm going to write like this. If you see what I did there. All right, the graph of a quadratic creates a parabola. So the quadratic is the function, parabola is what we call the shape that it makes on the graph. And we have our axis of symmetry right there. All right, we had three forms that we can write a quadratic equation in. So standard form is the one that we use often because we use it for quadratic formula, completing the square, and factoring. I think vertex form is the fan favorite because that's the one that is easiest to look at and locate and graph. But then there's also intercept form, and that one is also known as factored form. So I'm going to write, I'm going to use P and Q again, which I did in the unit also. All right, moving on. And again, if you need to pause the video to fill in what I've written. So characteristics of quadratic functions increase and decrease. And that changes at the axis of symmetry, which is another characteristic. This is the only one of our functions that has an axis of symmetry. And since it's vertical, keep in mind that it's x equals. It is symmetric, which is the only one that we've done so far that's symmetric. Our parabolas have a vertex, and there is not a constant rate of change. So we do an average rate of change, even though we still use the same formula. All right, moving on to exponential. So for exponential functions, I'm going to write like that. All right. When we graph an exponential function, we get an exponential curve, and it can go in different directions. I'm just sketching that one, something like that. All right, our most common exponential function, the standard form, would be our a times the b, which is the base, and then it might be shifted right or left and up and down. So that's the standard form for that one. But we also did growth and decay. And our growth and decay formula is very similar to this one, except our base number is going to be our rate added or subtracted to 1. And then we also had the compounded formula. So whenever we do compound interest, that one was, again, similar, except we needed to take into account the number of times per year the interest is being compounded. So that one's a little more complicated. All right, characteristics that are unique to exponential. This one is the only one that has an asymptote. And since it's horizontal, it's a y equals. We connected geometric sequences to our exponential functions. So if we take our first term and multiply it by the common ratio n minus 1 times, this one can be increasing or decreasing. So that's similar to the linear. So it's going to do one or the other, not both, like our parabolas do. And once again, since it is not a line, we do not have a constant rate of change. We have an average rate of change, and again, we still use the slope formula for that. All right, so what's going to be happening is that we are going to be looking at different functions based on their graph, their equation, description, word problems, and we're going to be distinguishing between which function we're talking about and then writing the appropriate equation to match the function.